Hi guys, this is week 6, and we're going to go over my Prisma connection and the Postgres SQL relation, along with our server and some of the things that are going on. All right, so uh, where do we start? Let's start with Node. Node is, as we learned in previous lessons, a single thread event loop, right? And that means every time somebody uses our server to make a connection, they need to query our database that causes some computational overhead. And we do something called pooling to actually kind of cut this down some. What pooling is we take a handful of use cases that we have for querying our database, and Prisma will do that for us. This is called pooling, and uh, it's it's just a connection left open while our server's running. This is beneficial because it's perpetual data. Even if our server shuts down, that's the memory card of data all the way up to the point that our server shut down until it reconnects. Um, Prisma being the nice framework library, whatever, that it is, works on an ORM, which is an object relational mapping, which makes the database tables and things like that look more like objects, OOP style for JavaScript. And um, that's one of the cool things about Prisma is it allows you to talk in the language of your choice to your database. I think that's how that was worded. I thought it was odd, but hey, that's a cool feature. Um, let's see. We did pooling. What's next? Hold on, sorry. 1 minute. Okay, things that make Prisma pretty good are that it does some slight indexing for speed for you. Um, as well as because it's an ORM, the way you query things and do stuff tends to look like objects, which is really kind of just native to JavaScript. So it goes from looking like the regular query language of Postgres to object-oriented programming, which is, again, native to JavaScript users. Uh, One of the things I didn't really care for is that you lose some things like joins, and some of your group by features, or it doesn't like them, I guess. But as far as running decent queries and error handling, uh, and slight indexing for your database for stuff that you do, I guess, it's very useful and handy as far as getting things done efficiently and quickly. Plus, I mean, if you understand OOP, it's not hard to relate an object to the query and how Postgres queries. Oh, yeah, let me bring this up. So this here is how we reach out. As you can see, we got our pool here. We reach out, highlight, there we go. We reach out to Postgres. Um, Telling it we want to insert the email name and hashed password as we would. And then because of the way the query language SQL works, these are our placeholders for these values here, right? And then we return, or we tell it to return what we want to see. We don't need to see the hashed password, so we don't do all that. Um, and then we go back to, let's go over here, task user, and this now is how we tell it. We say Prisma user create instead of insert, a little more intuitive in that sense. You know, you're creating a record. This is the data we're sending, and in that data should fulfill what their insert is wanting. Prisma, I wanted to call it Prism. Prisma does a lot of those things for us behind the curtain, kind of abstracts it away. So, hey, this is the data. Bam. Prisma's the one that writes that query insert for us and everything. And with the select, we tell it what we would like back. As you can see, we have this error handling down here, which they have a lot. Okay, it's not on here, but let's see if I can. Anyways, I digress. I'm sorry. Uh, so okay. I think that's it for the explainer, speed, credibility, find, insert, select. Cool. Yeah. Okay, so now I get to show off some of the things that go on here. So we have our schema here for our SQL Postgres database. And as you can see, we've talked about a lot of these things. I'm not going to go into super detail, but we do have a serial unique key where this increments. It's uh unique so that you only have one of them in this table. All right. We have these um constraints, not null values. I only repoint these things out, this Boolean, because as we run to our schema over here, this is our Prisma schema, we ran a command that took this data and did Prisma magic and then spit this out, essentially meaning the same thing, this ID being an integer that it auto increments defaults. Uh, we have more defined relations amongst fields compared to our schema, which is kind of this. Um, but we reference the tasks in the user. Then in the tasks, we reference the user's ID. These are unique ways to sort through the database and one meet some of Prisma's criteria for specific ways they would like operated because sometimes you need two unique keys to access certain bits of information. So no, I don't think they did that in the database for Prisma, but it's good to know those things. Let's see. What else am I missing? I don't want to get into the Postman quite yet. Controllers, we went over how they look. The Prisma.js, our pool connection. We talked about that already. Um, create task. I guess it is time to Postman. Let's see if we can do this correctly. All right, my server's open. Close some of these and all right, so we are going to go to our register success. Um, well, let's go to body here. We see that we have a success. It's created. Um, we have some tests that we get our 201. This is basically a lot of the same tests that we had on our assignment, but let's go to create. This also sends a create. As you can see, uh, infinite loop, that's what that is. Anyways, creates the task. So all these endpoints hit. I also have some tests for this. Just basic stuff. That is it for Prisma and the integration to my project. Thank you for being here, and I hope that covered everything.